Hello, viewers. So welcome to today's live coding session. Actually, I felt like not doing today's stream, but I just had to keep going. So our last stream was the last time I streamed was on Saturday, and before then, I think the issue that I had was, by the way, my name is Ebere Abanonu. So, the purpose of this streaming is to show you my workflow, how I do things behind the scene, behind the scene for. I think it's just basically to show you behind the scene for SharpPulsar, a Apache Pulsar client library that I'm the author of, based on aka.net. So that's the purpose of my live stream for this for the past few days now, because I'm actually working towards releasing SharpPulsar 2.0. So I'm just showing you the behind the scene, the bugs that came my way while working on it, the issues, the challenges that I've encountered while working on it. And I also feel it's also an opportunity for viewers to also gain deeper knowledge or deeper understanding of SharpPulsar, not only SharpPulsar but also to gain deeper inner understanding of the inner working of Pulsar itself. So that is the essence of my live stream. Like I said earlier, I felt like, well, I just have to keep going. So what I was saying before was that on Friday we tried to create a key cluster for us. That was last week Friday. A kind cluster for us to run local cluster of Apache Pulsar. We were successful in doing that, but we had one issue, which was that the broker wasn't starting. That was the issue that we closed the day with. And on Saturday, we opened the day with the same issue for about almost 3 hours. We were trying to figure out what the issue was, which was why the broker wasn't starting, which was due to the number of ensemble that the broker was expecting was 2, because we set the quorum to be 2. So the broker wasn't saying the second one. It was stuck on waiting for the second broker to start. So it fixed it to 1. We got it started. Then after then, the issue we encountered, or I encountered rather, was that I wasn't able to communicate with the broker container or broker proxy, which was an issue. So I tried to understand networking, how I could bypass that from to get access. I actually tried several configurations that was recommended by the kind documentation. It didn't actually work. The issue was that kind wasn't actually exposing the container port end port outside the cluster. So in order for me to fix that, what I did was, thanks to I went online and I saw, let me not pretend that but I saw a particular, let me see. Okay. So I actually saw this online. Sorry, let me switch to my I need to go down. So I saw this article online that gave me an insight that I need to do port forwarding. So I did the port forwarding. It worked. I was able to communicate with the the Pulsar proxy service within the kind cluster. I did that, and I also tried that. You know, one of the purposes I went this route was because I was actually running a standalone Pulsar instance, and I kind of felt like with everything I did, transaction was failing. I felt that probably there was something I missed with the standalone configuration. So I felt like, okay, maybe I should just run a cluster that is each component of the main component, bookkeeper, zookeeper, broker, running on their own dedicated node. That is, I did a three node cluster of Kubernetes. So I did that. I started yesterday. The transaction was actually still failing. So that means that I needed to roll up my sleeves and I had to look at my code to actually pinpoint what would have caused such. And luckily for me, I was able to actually narrow it down to the reason why the transaction was actually failing. So we're going to start our session with this, and I'm going to be showing you So I'm going to be starting our session with that, and I'm going to be showing you what was it actually that gave me a hell of time with transaction with my code base. The truth is, it was a good issue that I needed to encounter because one, first of all, before I was able to narrow it down to the bug, I was actually doing something wrong. Let me show you. Let me use my code to explain to you. There's I have to remember what I was actually doing. Okay. So what I was going to say is that thanks to the bug, I was able to actually understand that I was actually doing something wrong on this block of code, which was that, due to the asynchronous nature of the actor model, everything I do on this was to fire and forget. That is, I just forget it. And it was possible for instance, now I've sent registered produce topic registered to the transaction actor. I sent it, and at the same time, I'm also sending it concurrently. I'm also sending the message concurrently at the same time that I'm sending the registered produce topic to the transaction, which means that there's a possibility that the message will be sent before the topic get registered as a transactional topic on the Apache Pulsar. So that error led me to actually look at this a little bit further. So, but this wasn't actually where the error was. The mistake wasn't here, but it was good. The mistake wasn't here, and the mistake, I also did a mistake I didn't know until I started expressing the issue. So let's move on. So where the mistake is, I have so I'm going to show you where the mistake is. Let me continue. So this was where the mistake was. So I had, when I was testing with because when you instantiate a new transaction, you get the least byte and you get the most byte. So in our case, before I was able to detect it, was that I was actually saying if, for instance, the least byte is greater than, and when we have 0, it doesn't work. It skips this. And when we have 0 here, it also skips this. So which, in other words, tells Apache Pulsar that this is not a transactional message. So what that means is we consume the message before the transaction is being committed, which was wrong. So the fix was to check if it is equals to or greater than 0. Previously, I was doing it greater than 0. So if the least byte or the most byte is equals to 0, that means my code presents it to the Apache Pulsar server as a non-transactional message. So to fix that, I needed to add a greater equals to. So this was actually the issue that I was facing. So now I've seen another where I needed to fix this as well, which I never saw before now. So I also need to fix it here. So I was actually skipping. What this means, previously I was actually skipping the transaction ID or the message when it is transactional. That was what was happening. So I fixed that, and I've tried the transaction endpoint. Let me show you. Let me run a quick demo. So I'm going to run a quick demo so that you see what I'm saying. So I don't know. While I was running this demo, my the Visual Studio kept crashing. I don't know why. It kept crashing because I was adding the breakpoint, and at that particular breakpoint, it was actually crashing. But what I'm going to do is I'm not going to debug it. I'm not going to run the application itself. But before I do that, I need you to see. So now, this is the code we are going to run. We are seeing that we are producing the message with transaction, and you shouldn't be able to read messages while the transaction is not committed. So you can see I added one here so that we know once we consume on this line, we know that the transaction has failed or the code is not working. But once we commit it, then you should be able to read the messages, and you have 2 here. So I'm going to go to I'm not going to run it in a debug mode. I don't know why my VS 2019 has been crashing when I add the breakpoint. Probably maybe due to high memory usage. Probably that is the cause, but I'm not going to do that. So I'm going to move on. I'm going to go to. I'm going to delete the log that I added previously. So let's run the okay, you can see, as I've said, you can see we are saying in a square bracket, that is the second block of code actually worked. Why the first block didn't work? Because you have the transaction had not been committed. So this won't work, or the consumer won't be able to consume message from the topic because the transaction has not actually been committed. So once we commit it on line 10.8, then the message can be read. So 2 here as an evidence. This is 2 message received. We didn't get anything. There was no any form of output here because the consumer couldn't consume the messages due to the fact that transaction has not been committed. But once the transaction has been committed, we are able to read the message. So before this, I actually was I had to do a lot of digging. I read this article by Stream Native that talks about how the transaction works, in case you are interested, and also read this deep dive. There's a deep dive I saw. Okay, this deep dive actually gave me a little bit of insight. I was a bit confused. I don't know. I spoke to one of the. I sent a Slack message to one of the Stream Native engineers because I needed him to be a guest on this live coding session, but I don't know whether he has not replied me, probably due to the fact that he has not read it. But I actually wanted to verify something that has to do with this. Now, you see that according to the transaction, according to how transaction is implemented, there's a little bit of confusion. Now, if we are to create a consumer, like we said here, consume, then this consumer should be able to read the message. So I'm wondering why this consumer, if you look here, is actually reading the message before the transaction is committed. I don't know. I wanted him to be on this live coding so that we could interact and understand why they wrote this code this way, because actually it's confusing. It confuses. Well, due to the fact that I'm a programmer and my code wasn't actually working. But looking at this example, to me it feels wrong. It feels inaccurate because we shouldn't be reading a message when it's not committed, but they're actually reading a message before it is committed. This is what this example here actually talks about. It talks about the ability. I think I was also reading, okay, probably that is the case. I was actually reading the design document. I think it says something like uncommitted. So I think they are talking about the ability to read uncommitted. That means if the message is not committed, the consumer should be able to read it. Probably that is what was Okay. He said the isolation level that Pulsar Transaction must support is whether to support. So probably this is what was going on. Maybe they said it in such a way that you're able to read the isolation level. It was set to read uncommitted. So if the message is not committed, then the consumer should be able to read it. Probably that was what they did. I don't know, but judging from my own issues and from my own digging and deep, I feel like this is actually misleading. So I don't know if one of the Pulsar developer could, if we get to talk, probably we'll talk about this. Why this has to be so? It's actually misleading. Because anything that probably you need to understand, why not? So we are going to continue from where we stopped we before we had an issue with transaction. So I want to look for my last commit. I'm looking for a commit that I did on my GitHub. Okay, so before we actually went to we actually had issue with the transaction, which thankfully I've been able to fix. And please, I need you to subscribe to my YouTube channel because there's still more to come. So before we actually went there, there was three particular issues that I needed to fix with when it comes to producer end of it. The issue was that I needed to kind of re-implement the send messages, then actually also understand what the verified local buffer is not corrupted. Now, a verified local buffer might not work here because they are using native for their network communication. And I think another one is this context close. I think I've been able to do I've had the understanding on how I could solve that line 3, line 51 or 54 or so, and the resend. But the other verified local buffer is not corrupted. I might just keep it because it has to do with native buffer within corrupted native buffer and other, which I'm not actually making use of. But I'll see if I actually need to do that. I will do that. So folks, this is going to be our focus for today. So sit tight and let's take a ride. There's actually a video that I'm seeing on Twitter. It's a kind of funny video anyway. Has to do with Kubernetes. So let's move on from there. So I want to go to our producer. So I actually have my cluster running, local cluster. To actually, let's verify, because I actually have in addition to the I think in order not to what will I call it now? In order not to overload my memory, I think I did one master and two worker node. So this is actually my Apache local cluster running. So let's look at the booking. Which node is being assigned to worker 2. Let's look at the broker. It's assigned to the first worker, that is 1 here. What I mean. So here worker 1, that's the first worker. Then let me look at the zookeeper. Okay, zookeeper, because I'm working with two nodes, so that's why it's assigned to the same worker with the broker. But on a production environment, it's recommended that it's not on its own node. So let's look at my proxy. Okay, it's also working the same with. So that is, they are both they are both deployed on the first node, and while the bookie or the bookkeeper is deployed on the second node. I think that is why I actually wanted to try this. Yeah, to distribute Pulsar's components across different nodes. I mean, if I created, let's take it that I created additional node, that is 3 nodes, they will all be a separate node in their own instance or in their own standalone environment. So that is that for that. It was actually it was a nice learning opportunity for me. Kind cluster, deploying Apache Pulsar on it. It was fun, actually. It was fun. So let's move on from there and let's go to the business of today. So the business of today is resend line 1084. Okay, this is the line here, and what it says is that when we recover from checksum error, we should resend the messages, but due to the it's not corrupted, as message is not corrupted, let producer resend pending message again, including checksum paid message. problem now is how do we okay, there's actually an issue. Okay, let's look at the Java implementation to actually see to get this to work. It means I'll probably need to move this outside this place. Because we only need this when we first create the producer. That is this producer queue that add the producer. We only need it when we first create a producer. So, but let's see. I got a message from. Let me take it off the screen so I can reply to him. So I'm trying to understand how the resend message was actually implemented, and it's being used in how many places here? This is 1, 2, okay, 2 places. So I'm trying to understand what to do with this. And then I think I'm more particular about this line. If change to ready, take. Okay, let me see. If message is equal to 0, so let's continue from where we stopped. So I'm trying to look for other references to direct connection. This is only place in reference. Handle send error. Okay. Handle send error. So when we are sending a message and there's an error, we handle the error. Then we kind of try to resend it.